All right, for this reaction, I'm looking for the rate law. And if the first step was the slow step, the rate would equal K times O3 because that's the only reactant, and that's not it. So I'm going to assume the second step must be the slow step and that the first step is fast. And when we assume the first step is fast, we assume it's so fast it reaches equilibrium, which it shows here as well. So I'm going to write the rate law for my slow step, which is K times O3. But I can't leave it like that because O is an intermediate. Oxygen is not in the original reaction, the overall reaction, so I have to get rid of it. And I do that by using that fast equilibrium step. And equilibrium means that the rate of the forward reaction equals the rate of the reverse reaction. So now I can write the rate for my forward reaction from my first step, which is K times O3, and I called it K1. So then I'll call the other one K minus 1. So I'm going to go ahead and label those. -1 there. K2. All right. So I'll call the second one K2. Doesn't really matter what we call it. But anyway. And then the reverse would be the products, would be the reactants, right? So it would be O and O2. And that's all equal to each other. Now what I'm trying to do is get rid of O. So I'm going to solve this equation here now for O. Get O by itself. So I'll divide by K to the -1 and O2. And get O by itself. All right, so that's what O is equal to, and I can go back to my original rate for my slow step and plug it in. So the rate of the slow step is now K2. Instead of O, I'm going to write K1 times O3 over K -1 times O2, and then I still have that O3 from the original slow step rate. Just showing you where I got all of that from. Okay, now I can simplify it by reducing all these k's back down to just one k. They're all constant, so if I just multiply them and divide them, it's just a number still, so I'll call it k now. I have two O3s on top and an O2 on the bottom. All right, so taking a look at the rate that they gave me, they match. So that's good. I have derived that mechanism. The only things I had to assume were that the first step was the fast step and that it was fast enough to reach equilibrium, and that the second step was my slow step.